Okay, so we're going to first start by looking at the notes from Thursday. Now, if you remember, we talked about how to simplify a rational expression. And what that involved doing is factoring by greatest common factor or by factoring a trinomial and then canceling out or making 1 anytime the numerator and the denominator were identical. So let's start with this one right here. So how you can look at this as two separate entities, 21 times a squared over 7 times a cubed. And so you can physically break that apart. And so 21 divided by 7, that's really easy to simplify. 21 divided by 7 is 3. A squared divided by a cubed leaves 1 on the top with 1a on the bottom. Similarly, 2 minus 3 would be a to the negative 1, and anytime you have something to the negative 1, it goes in the denominator. So then you could multiply 3 over 1 times 1 over a equals 3 over a. Now, this is the simplified form of what 21a squared over 7a cubed would be. Let's look at this one right here, c. Now the top, 2n minus 3, that doesn't really have anything in common. But the bottom, you can see the 6n and the 9 have a 3 in common. So we can factor using a greatest common factor. 2n minus 3 over, they both can be divided by 3. That leaves 2n minus 3. 2n minus 3 over 2n minus 3 will cancel each other out and leave you with 1 over 3. And if you can understand that, then you're probably going to be in pretty good shape because it doesn't get too much more difficult. If you look down here, oops, when you're dealing with a trinomial, same difference. Let's look at a here. 2x minus 8 both have a 2 in common. That would leave x minus 4. And then now we have to factor this trinomial. So what multiplies to get negative 8 and adds to get negative 2? It would be x minus 4 and x minus 2. Again, the x minus 4 over x minus 4 cancels each other out, and that leaves us with 2 over x minus 2. So that's just a quick summary of what we did on Thursday. There's just one little thing we need to add to that prior to moving on, and that is talking about excluded values. So what does it mean to be an excluded value? Well, if you think back, any fraction can exist so long as there is not what number in the denominator. I want you to think about it. Think if you can remember. Well, hopefully you recall that any fraction can exist so long as 0 is not in the denominator. If you remember, that equals undefined. And if you look in your calculator, 5 divided by 0 says error, divide by 0. You cannot divide by 0 because that makes it undefined. Similarly, if we showed it as an actual fraction, 5 in the numerator, 0 in the denominator, you get the same error message. You cannot divide by 0. And so when you see this terminology of excluded values, you're going to find out or try to calculate what value of x makes the denominator 0. And so what you're going to do is you're going to factor where you can. Either do the greatest common factor or factor the trinomial, but before simplifying, before crossing things out where the numerator and denominator are the same, you're going to set those values in the denominator equal to 0 and solve for x. Similar to what we did in the last chapter when we were finding x-intercepts. So recall that letter A here equaled 3 over A. What value for A would make the denominator 0? Well, this one's pretty obvious. 0. If you plug 0 in for A, and you substitute 0 in for A, it makes it undefined. To follow my suggestion, A equals 0. So that is our excluded value. So A can be any other number in the world, positive or negative, as long as it's not 0. So when we look at C like we did, remember, factor where you can. Over 3, 2, and minus 3. Now, in this case, before you simplify, before you cancel out the 2n minus 3, you're going to set the two factors in your denominator equal to 0. 3 equals 0, which just doesn't even make sense. So we can discard that. And 2n minus 3 equals 0. So then we just solve for n. Add 3 to each side. You get 2n, whoa, 2n equals 3. Now you divide each side by 2. N cannot be 3 over 2. If n were 3 over 2, then that would make this 0. 0 times 3 is 0. And that would make our denominator 0, which would make it an excluded value. So our final answer when we're simplifying a rational expression is the simplification. So as this would be 1 over 3 with the excluded value, n cannot equal 3 over 2. That is the final answer. So you'll see that come up frequently as we move on. Before you simplify, you have to find the excluded value. So if you have any questions, you can look at chapter 11, section 1 in your book, or you can send me a message, I'll try to explain it, or you can just rewatch this until you get it. It's really pretty simple. What value, if you plug in for the variable, makes the denominator 0? You can't have a denominator of 0, so that value would be an excluded value. All right, this would be a good place to pause and take a small break if you need to. We're going to move on to section 11.2 and point 3, which is operations. And so we'll get more practice on simplifying just by doing these operations. And really, it's no different than regular fractions. We just have letters now, and we have to follow our variable rules and then do our simplification. So if we look at number 1 here, I'm trying to make this full screen and see if it's better. So if you look at, actually let's keep it here in case I need to use the calculator. So before I go into too many examples, let's just look at a number, or an example with numbers. Let's say I want to do the fraction 1/2 multiplied by, multiplied by 2/3. When you multiply fractions, you multiply straight across. 1 times 2 is 2, 2 times 3 is 6, or 2/6. And then obviously 2/6 would reduce down to 1/3. 1 times 2 is 2, 2 times 3 is 6, 2/6 reduces to 1/3. The same exact rules apply when you multiply rational expressions with variables. So let's look at, I'm messing everything up. There we go. Sorry about that. So we have 5 over y times 3y over y cubed. Now, so there's a few different ways you could do this. You could multiply straight across and then simplify at the end. So we'll first try to factor, see if anything can factor. But 5, 3y, y cubed, and y, we can't factor any of that. So you could do one of two different things. Multiply straight across. 5 times 3y is 15y over y times y cubed, which is y to the 4th. And then we can simplify. Now remember, we have to do our excluded values. What's the only way that these two denominators could be 0? Well, the only way is if y were 0. So y cannot be 0. So now we simplify this. The 15 has nothing to simplify with, so just 15. Y divided by y to the 4th is 1 minus 4 is y to the negative 3, or y cubed on the denominator. And that's it. That's our answer. Now when we get to number 2 here, it's slightly different. First step is try to factor anything that can be factored. X minus 9 cannot be factored, 4x cannot, x cannot. Let's use a different color. 2x minus 18 can. They both have a 2 in common, which would leave x minus 9. So now, before we simplify, before we cross anything out, we do excluded values. X cannot be 0. Because if x were 0, then this fraction would have a denominator of 0, and then 0 times whatever this is would be 0. So x cannot be 0. And then we also do this. X minus 9 equals 0. We solve each side for x, plus 9 on each side. X cannot equal 9. So any number in existence aside from 0 or 9 can be plugged in for x and get a real solution. Alright, so now that we found our excluded values, we can do one of two things. We can multiply straight across and then simplify, which is what we did up here. So let's try that. X minus 9 times 4x. Well, 4x times x is 4x squared, and 4x times negative 9 is negative 36x. And then 2x times x is 2x squared. And negative 18 times x is negative 18x. So you can see the kind of mess we create when we multiply straight across. This looks really intimidating to try to simplify. So what we do first is we can cross things out where applicable. So up here, if I would have seen that that y and that y cancel each other out, I could have went straight to 5 times 3 equals 15, and 1 times y cubed equals y cubed. So we're going to do that same thing here. That's why we factor this. So we factor this, find our excluded values, and then simplify. The x minus 9 and the x minus 9 cancel each other out. The x over the x cancel each other out. So all that leaves behind is 4 over 2. And how does that cancel out, or reduce, or simplify? To 2. So all of this simplifies to 2 with an excluded value of 0 and 9. So I want you to try this one. Number 3. So pause the video, try to factor whatever can be factored, and then find your excluded values. After you've done that, see what cancels out, and then simplify from the end. Go ahead and pause the video and try to do it on your own. Okay, hopefully you tried it. Just watch me complete it and see where you made a mistake if you did. Hopefully you did this with some relative ease. So, 5w minus 25. Well, we know that they have something in common. They both can be divided by 5. That would leave w minus 5. 5w minus 10. Well, they both can be divided by 5. Leaves w minus 2. W squared minus 25. Now this is a little bit more work. We have to figure out what multiplies together to get negative 25 and adds together to give 0. Hopefully you see that that's 5 and negative 5. So this would cancel out and become, I guess, W minus 5 W plus 5. So before you get all crazy and start canceling stuff out, you need to find your excluded values. So you set W minus 2 equal to 0. And you set W minus 5 and W plus 5 equal to 0. And then if you solve all three of these for W, you can see that W cannot be 2, 5, or negative 5. Because if W were 2, 5, or negative 5, it would make the denominator 0, and you can't have 0 in the denominator. So now we can just simplify. Well, W minus 5 over W minus 5 cancel out. 5 over 5 cancel out. So what we're left with is just a W on top with a W minus 2 and a W plus 5 on bottom. So we need to multiply this. W times W is W squared. Negative 2 times 5 is negative 10. Negative 2 times W is negative 2W. 5 times W is 5W. 5W plus negative 2W is positive 3W. And that's our answer. W over W squared plus 3W minus 10 with excluded values of 2, 5, and negative 5. So I'm not going to go over anything too much more complicated than this. You can see how, let me get the cursor here. You can see how with a trinomial it can be harder. Really all you have to notice is when something's by itself, it's over 1. If you see the word reciprocal, all you're doing is flipping that. So the reciprocal of this, of number 5, would just be 1 over this. The reciprocal of this would just be to switch the numerator and denominator. So it would be 2q minus 13 over 3q squared. And then you would just proceed to simplify it the same way as we simplified the last few. And so again, this would be a good time to pause if you need to. We're going to move on to the second page of these notes, which deal with division. Again, if you have any questions, rewind the video, watch, whatever you need to watch, back it up, watch it as how many times you need to, get it until you understand. And if you still are having troubles, send me a Canvas message. We'll see if I can walk you through it. Please just don't get intimidated and give up. We're still testing on this Wednesday, so we need to make sure we're doing all we can to learn this material. Okay, so division. I'm going to focus on 2 problems here because it'll show the gist. 7 and 9. And these types of problems are on the test, both of these types. Now, before I get into 7 and 9 into too much detail, I want you to think back to dividing fractions. So 1 divided by 2, so the fraction 1/2 divided by the fraction 2/3, for example. Now before I show you what this answer is, does anybody remember the rule for dividing fractions? Hopefully in your head you said that you need to find the reciprocal of the second fraction and multiply. So 1/2 divided by 2/3 is really 1/2 times 3/2, which if you can see would be 3/4. Let's see if our calculator gives us that answer. 3/4. So when you divide, you take the reciprocal of the second fraction, or you flip the second fraction and you change it to multiplication. So with that in mind, let's go back to the notes. So we have these two expressions. 12j minus 36 divided by 2j plus 4, that fraction divided by the fraction 3j minus 9 over 4j squared minus 16. Now, I will say that I'm not going to harp on the excluded values of division problems as much as I am with multiplication and regular simplification. The reason is because you would have to find 3 sets of excluded values. You would have to find that set after you factor, this set after you factor, and once you flip this to do your multiplication, you would actually have to find the excluded values of that. And I'm not trying to make this harder than it has to be. So for division problems, if you see a division sign or if you see a large fraction bar, don't worry about finding the excluded values. I know it says state any excluded values here, but that would be a great opportunity for bonus points on the test if you can state the excluded values of a division problem. What's more important is that you know this process. Because of this division symbol, you have to flip this fraction, which is called taking the reciprocal, and then do your simplification. So I'm just going to change this fraction to 4j squared minus 16 over 3j minus 9. And instead of division, we're going to do multiplication. Now we're left with the same problem we had up above. You need to factor where you can and then simplify. So let me make this 9 a little more noticeable. There we go. So 12j minus 36, they have a 12 in common, which would leave us with, that looks terrible. They have a 12 in common, which would leave us with j minus 3 over, these have a 2 in common. 2 is the greatest common factor, with a j plus 2. And we're multiplying that by 4j squared minus 16. So what we're going to need is what, excuse me, this one is kind of hard. You have to see what multiplies to get AC, which is negative 16 times 4 is negative 64. So what multiplies to get negative 64 and what adds to get 0? Well, hopefully you see that'd be 8 and negative 8. 8 and negative 8. Negative 8 times 8 is negative 64. Negative 8 plus 8 is 0. Now remember, because of this 4 here, you have to rewrite your expression. 4j squared minus 8j plus 8j minus 16. And then we factor by the grouping. So these two would have 4j, and that would leave j minus 2. These two would have 8, and that would leave j minus 2. So our two factors up here are 4j plus 8 and j minus 2. Now that's factoring review, so if you don't remember how to do that, you really need to get better at factoring. And then lastly over here, they have a 3 in common with a j minus 3. Again, I'm not so worried about excluded values. So now, anywhere that we can cross things out that are identical, we'll do so. Hold on a second. You'll have to forgive me, I made a mistake. 4j plus 8 has something in common. See, it can be simplified even further. They both have a 4. So let's and where I messed up, you'll have to forgive me, is remember, I broke my own rule. You have to take the greatest common factor first. These both have a 4, so we're going to pull a 4 out. And that leaves us with j squared minus 4. And so now, when we factor, we'll put a 4 here. What multiplies to give us negative 4 and adds to give us 0? And that's much easier to factor. It's just 2 and negative 2. And so it's j plus 2, j minus 2. And that's why you always try to find greatest common factor first, because you can save yourself a lot of headache. Now we can start crossing stuff out. J minus 3 over j minus 3, j plus 2 over j plus 2, 2 over 4, 4 over 2 reduces to 2 and 1, and the 12 over 3 reduces to 4 and 1. So all of that cancels out to where all we're left with is 4 times j minus 2 over 1. Or 4j minus 8. I know what a lot of you are thinking. That is way too many steps and it takes way too much time. I agree. But it's something we have to know and we have to be able to do. So bear with me here and try to do number 9. Now the key to number 9 is noticing that it's the fraction 5y plus 7 over 3y squared minus 18y divided by the fraction 5y plus 7 over y minus 6. So we can set that up. And I'm actually going to try to do a text box to try to keep it a little neater. Maybe I can put it off to the side. There we go. So 5y plus 7, we'll underline that, over 3y squared minus 18y. So there's that fraction. And then it's the division symbol, which I believe is right there. And then our next fraction, 5y plus 7 over y minus 6. So now if you remember, the rule is that we have to flip our second fraction or take the reciprocal. And so what that ends up becoming is y minus 6 over 5y minus 7. And we change that division symbol to a multiplication. So again, we need to factor. 5y plus 7, nothing in common. And that should be 5y plus 7 in there. I accidentally crossed it out. There we go. 5y plus 7 can't factor. 5y plus 7 can't factor. Y minus 6 can't factor. 3y squared minus 18y can. So let's do it. They both have a 3y. That leaves me with y minus 6. Perfect. So again, I'm not worried about excluded values when you're dealing with this complex division. Instead, take the reciprocal, change it to multiplication, factor, and simplify. So we can see y minus 6 over y minus 6, 5y plus 7 over 5y plus 7. That leaves me with 1 over 3y. And that's it. So again, you're going to have a lot of these problems on your homework. Rewind this video and watch it as much as you need to. Get with somebody in class that understands it, and you can work on it together. Your homework, which the sub should give you here soon, is going to look like this. It's just simplifying, factor and simplify, factor and simplify. And then you can see down here, I throw in some division and some multiplication. Don't overwhelm yourself. Most of the time, the most simple answer is the right answer. If you have any questions, feel free to shoot me a message. You're going to do the evens, and that's it. I was going to make you learn section 11.4. You guys have the notes for 11.4, but this has been a pretty long video, and I think I'm going to let you slide on this one, especially because it's the level I'm going to expect you to know it. It is so simple that it's not worth confusing you over right now. So you can forget about 11.4, just hold on to it. We'll touch base on it on Monday. So again, if you need to rewatch this video, go ahead. After this is done, you can start your homework. I want you to do the evens, which is 26 problems. It's 13 on the first one and 13 on the second one. Again, if you have any questions, I expect to see a Canvas message. When I come back on Monday and I hear a bunch of people say, I don't have the homework done because I was confused, I'm not going to accept that as an excuse. You need to advocate for yourself, ask questions, Google things, Khan Academy, Virtual Nerd. You need to do the things to help research areas where you're weak. I look forward to hearing from you guys. I hope you have a good day, and I look forward to seeing you on Monday. Have a good weekend.